We present multi-components rendering with curved axis revolutionary objects. Our method can render the novel view from single image of multi-components and curved axis revolution object. In this paper, we use the image decomposition technique to de-render the single image into multiple rendering factors, such as albedo, material, and environment map. These rendering factors allow us to generate the novel view or relight the image. Some methods assume the specific lighting environment and only work well in specific domains. Other learning methods that consider specular materials rely on synthetic data, and require the multi-view or multi-lighting image as supervision during training. Recent method, de-rendering the world's revolutionary artifacts present a model radar can recover environment illumination and surface materials from single image collections without 3D supervision and multi-lighting images during training. Radar make a simplifying assumptions on the geometry, they focus on rotationally symmetric objects. The radar model can re-render these vase from different viewpoints, or change the lighting condition. Rotationally symmetric objects' shape can be described by solids of revolution, which generated by rotating a curve about the main axis of revolution. We follow radar's setup, use a discretized radius curve to represent the SOR shape. However, the radar can only work well on the revolution object and the axis of the revolution need to be a straight line. And also radar can only re-render single-axis revolutionary object correctly, it can't predict the object components correctly. Such as handles. In this paper, we also use sweep modeling technique to extract the object from single image. 3-sweep presented an interactive technique to extract editable object from single image. 3-sweep can easily model the man-made object from single image using their interactive tool. However, 3-sweep can't handle the lighting condition in texture of the object. In our research, we adopt the ideas from radar and 3-sweep. We present a novel method that can re-render the more complex revolutionary objects from single images. We have two main goals. First, re-render the multi-component revolutionary object. Second, re-render the curved axis revolutionary object. Next, we will introduce our system overview. First, we use the 3-sweep object extraction tool to extract the components from input image. Each component object has their own 3D shape and textures. Then we use the extracted mesh and texture to generate new vertical SOR images. Also, we process the extracted mesh with the exist smooth and subdivision algorithm. Next, we use radar's pre-trained model to decompose each vertical SOR image into rendering factors. Finally, we combine all of these rendering factor and the processed shape of each components. In pre-processing step, we process each component mesh extracted from 3-sweep. We first apply exist smooth and subdivision algorithm to original mesh. Next, we generate a custom SOR mesh with straight axis to replace original mesh. The generated mesh has fixed height and width, and is 1-to-1 vertices mapping to original mesh. Then we use the texture that extracted from 3-sweep to render a new vertical SOR image. The vertical SOR image is used in decomposition system as input. Once we got the vertical SOR image and shape of each components, we use radar's pre-trained model to de-render the input image into multiple rendering factors. After decomposition step, now we have albedo, material and environment map. We also have the mesh which is extracted from 3-sweep and processed by our pre-processing method. We use a differentiable neural renderer to render the SOR shape. First, we use first 3 rendering factors to generate front view texture maps of each components. Second, use these vertices maps to sample texture from texture maps. Then, concatenate all vertices map and normalize. Finally, render our results. We conduct ablation studies to compare our full method, without smooth, and without subdivision. Due to 3-sweep modeling method, the extracted mesh without processing with smooth and subdivision algorithm are generally less smooth at bending object part. Our method can work well on curved axis and multi-components revolutionary objects. Via our method, we can re-render the vases from different viewpoints. Or change the lighting environment. Our method can work on not only vase-like artifacts but also some other object types in the world. Here are some results of the other object photos. Thank you for watching our video.